Okay. Good morning, everyone. My name is Pablo Meseguer. I work at the CVV lab here in the Universidad Politécnica of Valencia, and I'm going to present my master thesis, which is about deep learning analysis for histopathology images. As I told, I work in the CVV lab, which is a group that works on AI, and my master thesis is mostly focused on histopathological imaging and computational pathology. As my colleague Alejandro before explained, it consists on the digitalization of the biopsies and on the application of methods based on artificial intelligence. My work is mostly focused on cancer diagnosis. Last year, in this exact same forum, I presented what was my investigation at that moment that consisted on continual learning for cancer diagnosis. Continual learning is a kind of learning that humans do very well, because if we know how to differentiate a dog and a cat, we can know how to predict or to identify a horse. But this is harder for AI systems because of the catastrophic forgetting. When we train an AI system to predict a new class that it has never seen before, the model can forget the classes that it has previously seen. So what we applied is a multiple instance learning-based method for the classification of wall slide images in a continual learning framework for the prediction of different subtypes of skin cancer. Later, the investigation shifted to foundation models, which are a kind of models that know about everything. They can do any kind of task because of their pre-training, which is based on multi-modalities and very large and extensive data sets, mostly with the pre-training is mostly performed in an unsupervised, self-supervised, or a novel paradigm, which is vision-language supervision. We have investigated foundation models to the diagnosis of different, the same skin cancer subtypes that I show in the continual learning approach. We compared in this work 3 different models which were pre-trained under different learning paradigms. The first one, the ImageNet pre-trained models, which has been the mostly implemented in computer vision applications. But as you may know, the ImageNet dataset contains mostly natural images, so these images are very different from histopathological images, and the models struggle to extract relevant features from these images. So afterward, we compared 2 foundation models which have been trained with in-domain images of histopathological images, which are the B and C. B and B trained in a vision-language supervision paradigm, where the model learns the features from text supervision, and the other one is a self-supervised learning paradigm performed in an unsupervised manner based on contrastive learning. And finally, we have focused on vision-language models also for the prediction of different cancer subtypes. Vision-language models are composed of a text encoder and an image encoder. These 2 encoders extract the relevant features from both the text and the images. So what we pretended in the classification of different subtypes of cancer was to take advantage of the descriptions of a class, of a certain subtype of cancer, that these descriptions can be encoded by the text encoder, and with this information that we have in the latent space, which is aligned with the latent space of the images, we used that information to assess the similarity between the text description, which is an embedding, and all the patches within a slide. So if we can know which are the images, which are the sections within a wall slide image that are the most similar to the cancer subtype at hand, we will get a better representation of that image, and we can also tell the pathologist to focus on certain areas for the diagnosis of that type of cancer. And that's all. Thank you very much for your attention.